All right, let's get started. This time we're going to be working on battleships on the board. Okay, it looks very interesting. So let's start the time. Go. Given a 2D board, count how many battleships are in it. The battleships are represented with X's. Empty slots are represented with dots. You may assume the following rules. You receive a value board made of only battleships or empty slots. Battleships can only be placed horizontally or vertically. In other words, they can only be made of the shape 1 times n or n times 1, where n can be of any size. At least one horizontal or vertical cell separates between 2 battleships. There are no 2 adjacent battleships. All right. So in this example, there are 2 battleships, which is very straightforward. And the next example, which is an invalid example, we can't count how many there are because this could be 2 or it could be 1. I mean, it could be 3. So it's kind of confusing. So it's guaranteed that between 2 battleships, there will be dots separating them. Okay, so what do we do? Okay, so first of all, what are the attributes of these battleships? These battleships are represented with only one line. Okay, so I think if we can count them by their heads, you know what I mean? If we can count the very first, the top, if we can count them, if we can count the top head, if they're placed vertically, if we can count the top of the line of the battleship, and if they're placed vertically, if they're placed horizontally, if we only count the leftmost X of the battleship, and then we discard all the other X, right? Whenever we see a head like this, we increase the count by 1. Okay, I think we can do this. Now, so first of all, we need a counter. 0. And is it going to be a valid board? Yeah, it's going to be a valid board. So, for n is equal to 0 and its board I++. For I is equal to 0, I less than board dot the first element j++. Okay, so now the problem is if we want to count the head, if we want to count the head of the battleship, there are a lot of circumstances, right? Well, the head could be on the top left corner or on the bottom left corner, or if the battleship only has a length of 1, then it could be on the top right, and also it could be at the bottom right. And also the head could be in the middle of the board. So there are a lot of circumstances that we have to consider. So what if we, instead of counting the head, can we disregard the other circumstances? Can we see if exists the body? Can we see if the current X, if the current dot or X or the spot we're iterating belongs to a battleship, the body of the battleship, not the head, then we skip it. Otherwise, we can increase the count, right? Otherwise, we can increase the count. So I think this one has less conditions that we have to think of, because if X belongs to the body of a battleship, then it's guaranteed that it's not going to be on the edge. So we don't need to consider the circumstances where the X is. We don't need to consider the edge cases, right? Like when the X is on the edge. So we don't need to consider the boundary cases. So which simplifies the code. So let me check the time. Okay, we have 9 minutes left. So first of all, obviously, if board I and board J is equal to dot, then we can continue, right? Or if I is larger than 0, and so in this case, I larger than 0, which means it's right next to, it's right below the first row, right? Which means if it belongs to a body, then then it could be, well, say if the left, right, or the top, right? So the top could be I minus 1. So board I minus 1 J is equal to X, right? So in this case, it means on the first row, right? First row, I minus 1. So, which means the top is an X, right? And if J is larger than 0, and board, so if J is larger than 0, which means that, and if in this case, so in this case, if I minus 1, J is equal to, which means that on the first situation, we already consider that this spot could be in the body, like this is the vertical situation, right? This is the vertical. This is the vertical situation. And right now we're considering horizontal. Right? This is the horizontal. So I, J minus 1. So in this case, if let me see if I have time to explain. Yeah, I have enough time. So if the left of this, okay, so if on the other hand, so in another words, all right, if the left, right, if the top, right, in this case, okay, if the top of this current node has an X, which means this is inside of a body, no. And in this case, if so I minus 1, which means to the left. If the left of this, right? If the left of this node is an x, which means it also belongs to a body. This is not what we want, right? So, and then we can increase the count, which means it passes all the filters. So, and at the end, we should return the count. Let's test it. 2, 2. Oh, it's done. Great, accepted. Perfect. So I think the key point is this part, right? You don't want to oversimplify. So sometimes if you think it from the opposite way, it can save you time, right? Okay. Now, thanks for watching. See you next time. Bye-bye.